Hi guys, Mrs. H here. Today we're going to be looking at density. And so at the end of this slide show, we'll be able to define density, look at the relationship between mass, volume, and density, and calculate density. So what is density? So density shows a relationship between mass and volume of a substance. So a way of thinking of this is how much mass is there compared to the volume of this object, or just kind of layman's generic kind of thinking is how much stuff is packed into how much space. And so we can measure density using grams per centimeter cubed to the negative third, or grams per centimeter cubed to the cubed. I use grams per as opposed to the negative 3. It just in my head makes more sense, but you can see them both ways. So let's look at this relationship. So we've all heard the question, what weighs more, 1 gram of feathers or 1 gram of gold? And we know the answer is to try and trick you that they weigh the same. However, their density is not the same. Although the amount of mass each object is equal to 1 kilogram, the volume of these two objects is different. So because the volumes are different, their densities are different. If I take that gold brick, there is more mass in that space, the same amount of mass, but their mass is condensed into a smaller area, or sorry, not area, a smaller volume, as opposed to the pillow here of feathers. So the pillow of feathers has more space. There's more volume for that mass to take up. And so the volume is greater on the pillow of feathers. So when we're looking at the density of these two objects, the density of gold is greater than the density of the feathers, even though their masses are the same. What is different is their volumes, which results in their densities being different. So density is a predictable thing. We have density tables. Here is an example of some densities of different solids, liquids, and gases. Water has a density of 1, and so we can use this information to actually make predictions on whether or not something would float. We know solids typically are more dense, so they will sink because their density is greater than 1. But gases and even some other liquids that are less than 1, they are going to float in water. So an example would be if I put fruit, even though it's a solid, so remember it's the exception to the rule, fruit in water or even some mint or anything like that, this is actually because their densities are less than 1. And why is that? Why is it what counts for this? It's that these things, including fruit, animals and humans, are made up of 70% water, and we also have fat. And actually, fat's density is less than water. And so, because of this layer of fat, and the fact that we have the gas in our lungs, our density is less than 1, and so we can actually float in water. The one exception to this is sharks. Sharks actually have to swim to avoid sinking because they are actually denser than water. So let's do a comprehension check and see if you can answer these two questions. So how'd you do? Were you able to answer them? So now let's look at the equation. Mass over volume is equal to density. And let's see if we can put these into this equation into practice. And so here's an example. A ball has a mass of 39 grams and a volume of 6 grams. And so mass over volume, or 39 over 6, would be equal to 6.5 grams per centimeter cubed. And we want to make sure that we have that label on that answer because we need to know what the 6.5 means. So here are two problems that I would like you to try. The first one should be pretty straightforward, but on the second one, you're going to have to rearrange the equation to solve for the problem. So let's go ahead and give you a second to see if you can solve for these problems. So how did you do? First one, like I said before, it's pretty straightforward. So we have mass over volume, or 6 over 5. So we end up with a density of 1.2 grams per centimeter cubed. Now, in the second one, we actually need to rearrange the equation because we don't know the mass. We have volume, so we can put that in, and we have density, so we can put that in. And so in order to solve for grams or mass, we have to multiply the two numbers together by rearranging the equation, and we end up with 54 grams as the mass of this object. So how'd you do? Measuring density actually, what happens when we have a unknown volume or an odd shape where the volume for calculating is not as straightforward as just getting out your ruler. So Archimedes actually introduced this idea and how this works. And so we can actually put an object into water and measure the displacement. So how much does the water level change when the object's added to the water? And that displacement is actually going to give us a very accurate measurement of the volume. So on this instance, our water level started here at 15 milliliters, and when we put the rock in, it's displaced to 15 milliliters, and so the change is 5 milliliters. So that rock has a volume of 5 milliliters. This is Archimedes, part of Archimedes' principle, and he actually looks at relationships between the force and the buoyancy, and we can actually look at those displacements to actually calculate the force and buoyancy of these objects. So if you have any questions for me, please make sure you're reaching out to me. Bye, guys. Have a good day.